My name is Pascal. This is a series that I hope to make on philosophical topics, or really anything that I think is worthy of consideration and being talked about. And I wanted to start this off by talking about a book that I read during the pandemic that I think contains a massive amount of wisdom, and I think should be read by almost really anyone. That book is The Beginning of Infinity by David Deutsch, a philosopher and physicist. The Beginning of Infinity is a book that particularly that does treats mainly about epistemology, the study of knowledge and why it's important. And at first, this was a hard book for me to read, and it took me like 3 to 4 times for me to finally be able to finish it. It's because the book itself is kind of dense, it's hard to get to, it's complicated. And partly it's because at that time I had poor reading habits, reading books mostly when I was tired at the end of the day when I had nothing else to do. But when I finally got to finishing it, I realized that it was a book with so much wisdom and so much value that I think wanted to talk about philosophy, exposing these topics to a wider audience, specifically my own, mostly like Gen Z. I wanted to start the series off and talk about it. Now, what I'm gonna be doing is I'm gonna think about the most important concepts that I think, at least to me, are important to ethics. So, without further ado, is the beginning of everything. Now, if we're going to talk about knowledge, I think we should start at the beginning, or at least where the explosion of knowledge really started here in the Western world. Empiricism and empiricist philosophers, were one of the driving forces of the scientific revolution. They stood opposed to the dogmatism of the church and defended the holy books and writings. They strove to create knowledge and aimed to get to the nature of reality through scientific theories derived from sensory experiences. The general idea behind empiricism can be understood through the words of John Locke, stating, "Let us suppose the mind to be, as we say, white paper, void of all characters, without any ideas. How comes it to be furnished?" To this, I answer, in one word, experience, and that all our knowledge is founded, and from that, it ultimately derives itself. Simply speaking, in empiricist terms, nature is analogous to a book, and its laws are there to be read. One only had to observe with no preconceived notions, and then reason as to what nature's laws are. And though this made for a fine start for the rejection of the authority of the church and the beginning of science as we know it, because let's not forget, this is scientific revolution was the 16th century around, there are a couple of errors with this line of thought. First, how can knowledge of what hasn't been experienced be derived from what has? How can you claim to know something about a phenomenon that you haven't experienced and have that knowledge be from something that you have? If you were to experience a phenomenon that we can name phenomenon A and derive from it knowledge known as theory of A, what would make you think that this is a theory of law of nature, an observation that applies to phenomena B, C, or so on that you haven't experienced? In David's words, there's a logical gap. No amount of deduction applied to a set of experiences can reach a conclusion about anything other than those set of experiences. You can't make a conclusion about a specific thing and then ultimately take that conclusion to be applicable to other phenomena. So how do you face this issue? Well, it seems that repetition was what was used to strengthen theories and give them more weight. Induction is a reasoning tool whose principle rests on past experience as a way to make statements about the future. Simply put, the more often a specific experience happens under specific circumstances, the more likely that under similar circumstances, the same event would occur. Believing that when sufficiently similar situations occur, similar effects will follow, a principle named the uniformity of nature, and the tendency of the past to resemble the future, empiricists will make statements such as, for instance, where do we expect the sun to rise tomorrow morning? Because in the past, or so the argument goes, we have seen it do so whenever we looked at the morning sky. From this, we supposedly derive the theory that under similar circumstances, we shall have a repeated experience. This process of reasoning was nicknamed the inductive inference, and so this was how empiricists can claim to create new scientific theories. There are a couple of errors to point out with this. First, the theories and aspects of reality that science describes are often the bounds of ordinary human perceptual systems, and so this creates a question: how can these be the same systems that we create knowledge with? For example, when we look at the night sky with the naked eye, we see stars as tiny dots of light. That's the sensory experience that we have of them, but yet we know them to be hot balls of gas. And in regards to figuring this out, simply looking at them has been of no use. The second issue is with the principle of induction itself. The future resembles the past, the distant resembles the near. There are often justifications given weight to inductivism, but these are only true in certain circumstances. For example, the future resembles the past is only true within a certain time frame and compared to specific things in a way, and also in a way, statements like these have an undertone theory of them, which, as you remember, the empiricism claimed to the laws of nature should be read and the book of nature and no preconceived notions. But that's something that's very hard to do when you're trying to observe a phenomenon and come about to a certain conclusion. Because then the very fact of you choosing to observe something rather than something else, repetition also can be used, it can be also be the thing that you use to validate your belief. Because expectations brought about due to past experiences are not necessarily proof that the same experiences repeat themselves in the future. Bertrand Russell's a very funny quote to illustrate this, stating, "Domestic animals expect food when they see the person usually feeds them." We all know that these are rather crude expectations of uniformity are liable to be misleading. The man who has fed the chicken every day throughout his life, at last, rinses its neck instead, showing that more refined views to the uniformity of nature would have been useful to the chicken. The mere fact that something has happened a number of times causes animals and men to expect that it will happen again. Thus, our instincts certainly cause us to believe that something will rise tomorrow, but we may be in no better position than the chicken which unexpectedly has its neck wrong. So far, we've knocked down a possible philosophy as to how knowledge is created, but it seems that attempt was insufficient. So, how do we create knowledge? How do we truly come about it? Now, before I talk about the true ways in which we come about knowledge, it's important to understand that empiricism belongs to a tradition of justificationism. Within justificationism, one sees knowledge as essentially, or describes it as, a justified true belief. A belief is anything that you hold to be true, but certainly it's not because you hold something to be true that it necessarily is. So how do you make that bridge? How do you go from belief to a justified true belief and therefore knowledge? What you need there is evidence. What you need there is something that corroborates your belief. The evidence in this case acts as a sort of authority, because in this sense, to say that something is true is simply implied that you have a source to which your belief was confirmed, the proof or the evidence. So in this sense, empiricism upheld observation to be the touchstone of knowledge. Now, this doesn't really make sense of what knowledge must be within the context of what we are as humans. We as humans are fallible. We are error prone, and therefore anything that we do bears that touch. It shares that fallibility. And so there can never really truly be any sort of confirmation of belief as justified true belief and therefore knowledge, because anything that we can confirm, we will do so through our senses. We'll do so through our perception, through our cognitive capacities, which are, as I've said, fallible. The philosophical position that respects this is fallibilism. Fallibilism is a philosophical position that takes into context we are as humans and tries to conceive a relationship with knowledge that's more realistic. Fallibilism rejects this notion that knowledge is definitive and that there can be such a thing as definitive knowledge that doesn't really get improved on. And to prove how fallible we are, there's this theory by David Hoffman, a cognitive psychologist. He came up with a theory which states that evolution would have a tendency to reward species with perceptual systems that represent the world for the main purpose of survival, meaning the way in which we see the world might be shaped not for a worry of accuracy, with what is expedient, what helps us survive. And so if our cognition is fallible, our perception is fallible, then what follows our knowledge should be as well. And through a fabulous viewpoint, we're capable of constantly giving ourselves the possibility of viewing the concepts and getting ever closer to the truth. And for how we come about the truth, the real way is through explanation. Now, explanation, the way we come about knowledge, are mainly effort of conjectures or guesswork. Very educated guesses or conjectures, and through affirmation conjectures with a good dose of criticism, we create better and better explanations in our attempt to understand. Explanation of the ways that we come about knowledge are mainly an effort of imagination. Now, it's important to remark that our imagination creates falsehoods more often than it comes upon the truth. And so this creates the need for a criteria for what qualifies for a good explanation versus what is simply just a bad one. And for example, there's a Greek myth as an explanation for why winter comes about cyclically. The story goes that Persephone, goddess of spring and daughter of Demeter, goddess of the earth, was kidnapped by Hades, god of the underworld. And so Demeter negotiated the terms for her daughter's release, and they would be as follows. First, Persephone would marry Hades. Second, she would eat a magic seed that will compel her to visit him at least once a year. And whenever Persephone is visiting him, Demeter would go sad, and in her sadness, she would use her powers and make the world cold and somber and prevent anything from ever growing. And here within that, we find elements for what makes a bad explanation. It's an attempt to explain the regularities of the season, but it contains many elements not essential or useful at all to understand why it happens. Every element within a story could easily be swapped out for any other thing, and it would make exactly as much sense, at least as an explanation. You could swap out Hades, Ares, Poseidon, or Zeus, or really any other god in any other mythology, and that wouldn't change much in terms of the explanation's ability to, well, just explain. You could repeat this process with any other detail and you can still make it work. What the explanation really lacks is specificity or elements within the story that, if ever removed or swapped out, will no longer make sense of the phenomenon it's trying to explain. The reason that those myths are so easily variable is that their details are barely connected to the phenomenon, making them bad explanations. You can see what makes for a good hard-to-vary explanation by juxtaposing the Greek myth with a true explanation for why the season changes. Earth's axis is tilted compared to its orbit, a tilt around 23.5 degrees. So during half the year, the northern hemisphere is tilted closer to the sun, producing warmer seasons in the north and colder weather in the south. Rather than there with such an explanation, we get logical answers for weather temperature in countries closer to the equator, whether weather in countries closer to the equator doesn't vary as drastically as it does when you're further away. This, in essence, is what makes for a good explanation. Its elements are not easily swapped out. The details are directly related to the phenomenon they're trying to explain. Any attempt to change any part of the explanation will no longer make sense or explain the way it changes quite as well. Good explanation also have a reach, in that once you've identified an explanation and the elements that compose it, if those elements are present in any other phenomenon, your explanation will still apply. Even if the original aim was to explain weather changes here on Earth, you now have an explanation that can explain weather changes on any other planet, as most will have an orbit, an axis, and therefore weather to which your explanation still applies. All this, despite the fact that you've never, or probably will never, experience them. The way in which we understand gravity and the movements of planets within our solar systems has been through quite a few revisions across different periods in history. In the 16th century or so, we find the most popular conception of the universe to be the Ptolemaic Aristotelian model, wherein which the Earth occupies the center stage in the solar system, and indeed in the universe itself, with planets and sun alike revolving around the Earth. The orbit that traces is perfectly spherical and is made of ether. While it's Nicholas Copernicus, we go from a geocentric with the Earth at the center to heliocentric with the sun at the center. In 1609, Johannes Kepler writes his Astronomia Nova, making major improvements in the shape of the orbit, an ellipse, not a circle. And the second, a method to calculate the speed at which a celestial object travels at a particular place in its orbit. An improvement of major importance, as the Ptolemaic Aristotelian model couldn't explain the fact that objects change speeds at certain points in their orbit. In 1687, Isaac Newton submits Philosophia Naturalis Principia Mathematica, or Principia for short, a massive titan of a book laid in 3 shorter books. Book 1, De Motu Corporum, of the motion of bodies, the world's first introduction to calculus, which he invented, and its relation to the motion of bodies, objects, and free space. Book 2, De Motu Corporum Part 2, this time discussing objects and their movements to fluids. Book 3, The Mundus Systemati, on the system of the world, in which he lays out gravity as well holds planets around the sun and corresponding formulas. Newton's work laid out much of our understanding of classical physics, and his theories of gravity being the force responsible for tethering planets to the sun remain largely undisputed. until Einstein submits his general theory of relativity, in which he states that what we experience as gravity is really just a curvature of space-time in which objects, such as the sun, due to their mass, bend, thus creating the illusion of gravity. Each of these successive thinkers made improvement in what we knew to be true, and although they got some things wrong, what they got right lived on, revised, and more likely to be true theories. This is the process through which we create knowledge, by holding nothing to be certain, and now allowing ourselves the freedom to constantly change our minds about what we know to be true. All we do is guess, it's all conjecture, and through a fallibilist viewpoint, we can make better and better guesses, and thus increase our chances of getting ever closer to what is likely to be true.